Welcome back. Little upset that I had basically just recorded almost this entire video in my computer blue screen, so I lost everything. But this video I wanted to do something a little bit more exciting, I guess, than usual. Instead of just talking about different architectural patterns and designs where it might not make a ton of sense if you're not actively in the code base, I figured we would talk about some animation stuff that we have going on. And today I wanted to focus on essentially trying to get a death animation put in place for the NPCs that we have, and I guess the character as well, but ideally you don't die, um, and kind of walk through how we do that. I actually had coded all of this stuff live, not this part in particular, but some of this this death stuff here, and explain what was going on. So I'm going to backtrack. Unfortunately, won't see this part get coded live, but I didn't finish all of it, so we'll get to that and do some live coding. But I'm going to start by talking about this sprite sheet. And the nice thing is that in the game, all of the actor sprite sheets are done using something called LPC Universal Sprite Sheets. And I'm going to put a link to the description of the video, but there's essentially a tool, just pulling it over here on this window, that someone had built, and I'll put, again, links will be in the description, but it allows us to use a whole template that's consistent for getting animations for different characters. So you can, put leather shoulders on, you can put a hat on, a golden helmet, right? So like you can basically make all of your characters this way, export a sprite sheet, and then animate it, which is super powerful. So for someone like me, I'm not graphically inclined at all, and personally, I think kind of having to sit around and try and draw like this type of stuff I would never make any progress on a game. So this is kind of a lifesaver for me. But yeah, all of our actors are going to be using sprite sheets that resemble this format, which is great. So currently in the game, all that we can do is face a particular direction and stand or walk. That's all we've really had to do so far. And as we were testing out some pieces of the combat system, it was getting kind of tricky to do it visually because I couldn't tell if actors were actually dying. I'd have to check the logs or otherwise kind of use the back-end tests we have and step through it. But it would be really nice just to see the skeleton die when you kill it. And I was like, this will be a great opportunity for a video. So basically, if I zoom in here, you can see that there is a death animation right at the bottom. It's made of these 6 frames. So what we're going to be doing is make an animation that uses, from this frame here all the way over to this one. And I'll kind of talk about how we do that. So I'm going to jump into some of the code here. And we have something called LPC Sheet Animation Factory. So you might be starting to read through some of this on the screen, and something I just want to kind of address is that some people that are coming from like the Unity space or other helpful game creators and game engines, you might be looking at this and going, wait, like, why are you making animations in code? Why are you using all the tools and stuff that are there for you? Like, it's super easy. Just, drag a texture in or a picture and kind of, you can make an animation in like 30 seconds, and it's way better than this. So for sure, you're right. There's lots of helpful tools. I just wanted to kind of touch on this a bit. That number one, I get a lot of enjoyment out of building some of these things from scratch. I think it's a lot of fun to come up with cool ideas for how to do this stuff. Helps me learn, helps me understand what's going on, helps me tune it to the what's useful for me. Not that I'm ever going to make something better than what Unity or some other tool has, but it's a lot of fun for me. And then the second part to that is I actually have really enjoyed the fact that I am not directly coupled to Unity for this game. I think that's a huge advantage to how we've structured some things in our code base. Unity's great. We probably will stick with Unity, but there's been a lot of advantages to not being coupled to Unity. Like basically I can run huge parts of the game like simulated in like a headless mode or in unit tests. We can load the game up in WPF applications. None of that is Unity related, and it still works, which is really cool. So anyway, as a result, we're kind of making animations from scratch with our own animation system. And just to kind of elaborate on what's going on, I had mentioned that so this is the entry point to the factory, and I did mention that prior to this video being created, we could only stand and walk in certain directions. So that's kind of what this part of this method does. It's going to go make those directional animations for us. And what I had just added before my dreaded blue screen was this code here to create a death animation. And if you had noticed, the death animation only faces in one direction here. Right? It only faces forward, so it's not a directional based death. That's cool, nothing to worry about. But that's why it's not kind of going into the directional animations loop. It's going to be on its own. So if we look at how to make a death animation, this right here, it has a prefix. I'll explain that in a sec. The frames that go into the animation, and then kind of packs that into a whole little package for us called a sprite animation. And that false at the end here is really just whether or not the animation repeats. For a death animation, if our animation system works as I expect, we don't want the death animation to repeat, because it would show the actor dying and then all of a sudden stand back up and die again on repeat. Probably not what we want. The prefix I mentioned is sort of how our actor system works, in that we can do a lot of really cool stuff to switch the appearance of actors on the fly. And why you might want to do this is, certain skills like letting a player transform into a werewolf, or I want to design something cool that the player can equip and turns them into makes them look like a skeleton or something. Because all of the sprite sheets are LPC Universal Sprite Sheets, we can kind of interchange all of these things. And we thought that would be a really powerful way to design cool skills or cool item effects and things like that, we just kind of tweak the animation set that's being used by using a different prefix. So anyway, that's the idea here. So that's why we have this, and then really the bulk of the work is in the individual frames. So I had a bug the first time through when I coded this and caught it while I was recording the video originally. I've actually realized that the original thing was correct. So this should be a 6. This is the number of frames, right? So it says generates a sequence of integral numbers within a specified range, and I'm pretty sure the 6 is the count, right? So that makes sense. So we want 6 numbers starting from 0, and if I go back to here, again I'll zoom in, we have 6 frames at the bottom we want to use. 1, 2, 3, 4, 5, 6. So that's 6 frames, and we're going to make them over here. I think this is where I messed up before. So we actually need this to go from 172. I have Unity closed right now because I think Unity is actually what caused my computer to blue screen. So in Unity, when we load up the sprite sheet and slice up the sheet, we can see that index 172 is going to point us right here in this very bottom left position. So this is setting us up to go from 172 to 3, 4, 5, 6, 7. So we'll finish at 177. And if you're kind of looking at these two things put together, we're going starting at 0 added onto 172, and then 6 added, or I guess it's 5, right? Because starting at index 0, so the final number will be 5 added to here, which is 177. So we're going to get 6 frames from 172 inclusive to 177 inclusive, That's what this ends up doing right here. Each one of these frames we're going to try out at half a second, which means it will take 3 seconds for us to die. We'll see what that looks like. We can tune that. Cool. Some of the other pieces that go into the frame itself, just touch on that briefly. These two Boolean flags are whether or not we want to flip the frame. And then there's a duration, of course, and then this last one is a color, and that's really how we can tint the individual frame. So I'll give you a cool example. We're not going to do it for this video, but if we wanted to, oops, sorry, I went to the other, whatever, we'll stay on this one. I accidentally scrolled over. So this is the player, and if we imagine applying a different color over top of this, what we could do is kind of show like flickering between normal and like a red version as we cycle through these, and that might kind of make it look like the player is taking fatal damage or something like that and kind of dying because it's flickering red. So that's what this color does. We can kind of tune it per frame if we want, which is pretty cool, but we're just going to keep it the same and not actually mess with that right now. So all in all, this code, returning this will give us an entry for a death animation that we can use across every actor in the game. So we pay up a little bit of cost up front to go code this, but then we have it reused for everyone, which is really neat. So I kind of like that. And I'm not going to show it in this video, but the one I had done before, I just kind of proved very quickly that this code gets hit, and that we spot checked the frames that came off of this animation. So anyway, this gives us an animation. How do we actually use it? So what I had done was I was thinking about the only other spot currently in the game that tweaks animations, and that's our actor movement system. Systems in our game are hooked up to our game engine loop, and the update method for a system is called every time the game engine loops through. This one in particular is responsible for actually moving the actors. So you can see at the very bottom here it has this little update animation part. I'll dive into that. And this is pretty gnarly right now. We just added directions into the game, and they're not really a first-class citizen, so we gotta reorganize this a little bit. So it's kind of like checking animations to know which way it's facing right now, and that's not great. But anyway, all that it's doing is it's taking the animation behavior off of an actor and assigning it a new animation. And then everything else is kind of handled for us. So we're going to mimic this system, but instead of looking at input controls, we want to look at whether or not the actor has life. So that's what we're going to do. And I started trying to build this system before the dreaded blue screen. So I kind of copied and pasted some of what was below. We're going to move this to the right spot. What I had just realized before it crashed was we don't need a logger. And I'm going to explain what's going on here. So we have a hand-rolled ECS, so Entity Component System framework, and we're definitely going to need to stop hand-rolling our own and borrow a sort of a one that's better used, more widely used, so that we get some of these things are not so ugly to look at. But what this is doing is giving us a filter that will go through all of the game objects on the loaded map, and it's going to find us game objects that have these two behaviors with them. So because we're trying to do a death animation, the two things we care about are if it's something that can be animated, and if it has stats, so we can look for life. So as long as it has these two things, we can try to force a death animation on it. So hopefully that makes sense. So what I'm going to do is start filling out this update method. And I mentioned that the update method will be called on every sort of tick of the game engine looping through. And the reason for this comment that I added here was that for something like a death animation, we don't need it to be instantaneous. We're okay if it lags a little bit behind. And the example I want to give is that if our game engine loop was running 100 times in a second, we don't need like that kind of resolution to know if an NPC died. In fact, even like delaying up to a second in a 2D top-down game probably isn't the end of the world, but we can do much better than 1 second, so we're going to come back and revisit throttling as we need to for this. But every time that we update, we're going to pull off basically pairs of having stats and animations. So in order for us to calculate a stat, we want to do, we have something called an amenity, which is really like extension methods without the static classes that we've kind of come up with. I'll explain that more in a sec. So let me resolve that. And there we go. So this is probably too verbosely named and redundantly named, but the service part is kind of overkill. But we have this helper class that kind of wraps a whole bunch of stuff for us to make common operations look very easy. So it saves on a lot of code, kind of like what a extension method might do for you. It's very helpful. It's like syntactic sugar. That's what we're going to leverage here. And what it lets us do is get a stat value off of a game object, right? And for the stat definition ID that we want, I know that the stat definition ID for current life is defined on on this guy here. I'll go ahead and pull that in. If you're wondering what I'm doing by adding this stuff to the constructor, everything in our game is hooked up through autofac. And if you haven't used autofac before, I highly recommend you look into autofac or some other dependency injection framework. But the idea is that for the lifetime of my game, I only have one of these systems. I only have one I behavior finder, only one of these, only one of these, only one of these. And instead of trying to build up all my dependencies manually by passing stuff through constructors, I let autofac do that for me. It's been a huge time saver. Some complex scenarios can make some debugging things trickier, but I think overall it'd be hard for me to live without autofac now. So basically just by adding the dependency right into the constructor, because I know that these things are registered through autofac, I know that it will get injected as I expect. So combat stat identifiers has current life on it. There we go. So current life, but we don't have a game object, right? But we do. It's just not quite obvious. So because we're using an entity component system architecture, the entity here is it's the actor that we're interested in, but the two components we're dealing with are these behaviors here. And the entity is the owner of these components, so I can easily pull that off like this, and it's still going to complain. This is a sort of a big tech debt item that we have in our code base, which was definitely over designing something early on. And I'll explain that very briefly, but we had this interface that we were using called iHasBehaviors, and essentially iGameObject is literally the only thing that is iHasBehaviors, so we need to just replace iHasBehaviors with GameObject. So I like to leave these fixed me so I can go identify them later. right? So there we go. Quick note. Anyway, so this for us is going to calculate the current life of one of these game objects on the map that has both of these things on it. And then we can say something like if current life is less than or equal to 0, we want to do the death animation. Okay, so how do we do a death animation? Well, I think we have item 2 is the animation behavior, and we can do current animation ID is essentially this. But where do we get this from? Right, that's a tricky thing for us right now, and I'm going to kind of walk through how I believe I'm going to do that. This part is, as you can see, I haven't actually coded any of this yet. I have no idea if any of this is truly going to work, but that's why I thought it'd be fun to record it. So where do the other animations come from, right? Like, how do I know that I can get away with this? Where else was it working that's like this? And if I go back to this movement system that's down below, and by the way, I am going to move the top system out of this file. I'm only doing this right now just so I can easily flip between it, and then I'll move it after. Anyway, all the animations we had are on this actor identifiers reference. So if we want a death animation, we should probably stick that along with actor identifiers, because that's where all the other animation identifiers are. So let's go ahead and, oh, we already have that pulled in because we copied and pasted this one, so that's cool. Actor identifiers. Oh, the naming convention is N. Cool. Great. And that's it. But is it? Okay, so a couple things. Number one, we gotta go put this in play. We gotta go define that somewhere, so we'll do that. And then the other thing to think about is I mentioned that this updates every single time the game engine does a loop. So I'm very curious if by running this particular code, if we're already in the middle of dying, if this is going to reset the animation and kind of just perpetually try to make the actor die once it's already died. I don't know the answer to that, so if we dive into the code that handles that, I'm just going to quickly check if what is going on here. Some weird artifacts on the screen. There we go. Okay, so if we call set on here, it doesn't do anything. It just stores the value. So far so good, right? So if it's identical, to me that makes it look like so if we keep saying like set death animation, set death animation, the setter just stores it, and it's going to be a no-op essentially, because it will just put the same animation ID right into this property. So actually I think we probably are okay. My concern, as I mentioned, was that if we're in the middle of dying, because we've already set this, and the next time we come through the loop and we set it again, and I don't mean this loop, sorry, I mean the game engine loop that calls this, the next time it's going to set it again, is it going to reset the animation? It looks like the answer is no. So that's cool. So where do we get animation death set up? And the answer to that is part of this architectural sort of ongoing discussion I keep having in these videos, and right now we are in the game specific project, and our game is called Macerus, so we're in the Macerus project. The bulk of the engine is actually built in Project XYZ. It's only named that way because I couldn't come up with a name, so that kind of just stuck. That interface comes from here. So we have to go update the base game engine to kind of include this concept of a death animation. So where do we go do that? This project is got tons of organizational tech debt, so apologies for poking around quickly through here. But in our features section, under game objects, there's actors and actor identifiers. There we go. That's where all of them are. So if we add a new one down here, death animation, I have a really bad feeling that there's going to be a lot of spots in the code that want me to have like stubbed out classes. Yeah, that sucks. Okay, let's do it though. So this is just so I can get it to compile, essentially. So this kind of sucks. But I'm just going to kind of copy the same pattern blindly everywhere. There we go. So I'm just looking for sort of test areas, and I think it's really only that spot. So that's kind of cool. So yeah, we added animation death. That's great. Something that's probably worth calling out, and I'm actually going to leave a comment here, is because this is in the base game engine, the idea for anything existing in the base game engine is that we should be able to make other games that want to use this. So Masterus is a medieval role-playing, like high fantasy role-playing game. What if we wanted like a space game? What if we wanted some other role-playing game? Does it make sense for this set of things to be here? I don't know. Maybe we want to have different definitions of animations. Maybe this is truly game specific. I don't know. So I'll leave that as a thought for some point in the future, if and when we ever come back to this file. I like doing this just so I can keep moving forward, making progress, and then leave little breadcrumbs for myself. And if it keeps coming up, I'll make a Jira ticket and kind of address it later. But anyway, we added this one identifier to this interface. Let's go ahead and build this project. Building this project here is sort of like a cheat method for a continuous delivery system. I don't have or continuous integration system. I don't have like Circle CI or anything set up yet. We'll be looking to do that. So this is really just taking all these other projects. There's like 99 of them. So taking whatever of those 99 projects, adding them into a big NuGet package. Once that's done, we can then reference it inside of Masterus very quickly. So this one's just got to finish building. It's a little annoying, right, that just adding this one property, this interface, it's going to go compile a whole bunch of stuff to do that, but I think that's part of the NuGet generation process, because I don't think it had to necessarily rebuild everything in here, but we'll let that finish up. It shouldn't take much longer. And then what we're going to do is the spot in Masterus that actually defines all of this, it's actually a spot that looks very much like this over here, which is why I put this guy onto my clipboard. We're going to go find the spot in Masterus that does this. This one that we're looking at is really just for testing. It's because the dependency injection framework is going to expect that one of these things exists, so we have to satisfy that. And if we wanted, we could write functional tests that operate using this information, but that's another discussion. I'm surprised this is still going. Okay, all done. Good timing. Okay, so let's jump back over here. We're going to actually update the NuGet package quickest way based on some of the things we have built in. If I just say rebuild here, it starts restoring the packages. This part should be okay, but the part where we actually define our actor identifiers, which will be in our content project, that one won't compile actually, and that's because it's missing the property that I have copy it on my clipboard. Right, so actor identifiers doesn't implement it. Looks very similar, right? But it's a little different. It actually has this special syntax here. And I mentioned early on that we have this prefix system that lets us swap the animations very quickly. So we have this lookup that will just replace $actor with the type of actor and kind of give you that character sheet to work with, if that makes sense. So that's how we get that in there. Now if we rebuild this, we're getting closer. So this part, as I said, that should be satisfied. That's great. We actually have to get this system hooked up though. So let's go ahead and actually move this to its own file. That's great. And to hook it up, where did we hook this one up to AutoFac? We'll jump over to this module here. So this is like an AutoFac module. It's just all these registrations. If you're familiar with AutoFac, you might be looking at some of the patterns I have in here going, why do you do it that way? I have my reasons. I can make other videos on that. This works really well for almost everything I build, so I continue to do a lot of as implemented interfaces and single instance. There's many cases where I don't do this, but without exaggerating, probably 95% of the time this is what I end up using and it works for me very well. So here's where we register this accurate death animation system. Here's what we wrote, and let's go try it out. So I'm going to go ahead and build this again. Hopefully that builds. And I'm going to try to illustrate. I'm not sure if it still works actually, so it might not be the best way to do it. But I'm going to see if we can actually prove that this works without Unity, which sounds kind of funny, right? Because we're talking about animations here. How am I possibly going to show you this not in Unity? I'll show you in what we call our headless, so just our command line little test space that we're using as a little playground. But we have a exercise in there that essentially allows us to simulate a combat scene, so like an encounter. The skeletons come kill the player. I think actually the skeleton damage is too low now. Man. Okay, let's just go to Unity. We've been messing around with combat like all morning today, so I think the skeletons actually can't kill the player with their current setup now. So that kind of ruins that idea. But we'll go to Unity. I'm just kind of nervous it might crash my whole computer again, so let's find out. But yeah, this will be the visual way of kind of proving the test. While that's launching, I'll just jump over here and kind of show you what I meant though. We just have these really quick hacked up things in here called little exercises. There's one for actually being able to loot corpses, a combat exercise. So my plan was to use this, let the skeletons, they essentially come kill the player, just to try it. I was just going to put a breakpoint in our system and see if it works. So we're going to fly a little bit blind here, but that's okay. I don't know if I should be confident in this or not. Nothing ever works the first time, so if it doesn't work, I don't want to spend too much time on a video trying to debug it, but we'll see. And sorry for the Unity wait time. Like I said, I didn't want to have it running in the background again and risk another blue screen, so let that keep going. Yeah, I guess I could, while that's going, I could try running this. Right, combat exercise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, character death animation system. We'll let that run. Actually, I don't think I rebuilt headless. The rebuilding action is for us what pulls in new NuGet packages. Does like a NuGet restore with the latest versions. So I'll do that first. There we go. Now we'll run it. I still don't know if this is going to work because the skeletons might not kill the player. Unity's still chugging along. Wow. I wonder if that's because it crashed and it's trying to restore a bunch of corrupt state or something. So it's currently doing a ton of autofact resolution, which is why this is kind of stuck. If we look here, it's loading. You can see it's loading up a whole bunch of stuff into memory. Okay. Create death animation. This is where in the previous video I made that I lost, it was kind of showing here's what a death animation looks like. We can see that it has the 6 frames from 0 index to 5 index. Each one is half a second long. It has a sprite resource ID on it. So this is the last one. It should be at 177. Player male 177. Excellent. So we know that works. And cool, so I have a breakpoint in our actor death animation system. We can start doing checks on the life, which is great. I'm just pressing F5 here. The 100 I know is the player has 100 life, skeletons have 10 life. So F10 again, or sorry, F5, another 10 life. So it's just kind of cycling through the turns we have. And I don't think that the player is able to die from the skeletons here, but we'll see. So it's actually simulating the walking and then the attacks. But it's freaking out right now like this because the skeletons are doing negative 10 damage. Or I guess they're doing 10 damage or something like that. 0 damage minus 10 defense. So the skeletons can't actually kill the player, but anyway, that was the plan to show that. Unity seems to have loaded, so that's great. I'm hoping this is going to work the first time now. So we just showed that our system does get hooked up. It is doing proper current life calculations. It's really just about whether our animation is correct now. Now, it might be 1 frame off or something, but the kind of things I'm thinking are that it's either a frame off or that it's going to do something funny with how it's looping. Hopefully neither of those. But fingers crossed, so let's see. So we're going to go into our test map and start a test encounter with skeletons on it. It's the same thing that what you just saw the console program was doing, but obviously there's graphics despite them looking not so great. Okay. This is made a video on this for Gnosis. It gets into this state where it doesn't re-import our XAML assets. So I'll quickly just do this. Hopefully that addresses it. Yes, lots of errors. There's one other spot I just want to touch on super quickly here. Views, resources. We have a bug filed with them right now for this because it seems to happen randomly, or even after I've done this, it will sometimes say, oh, I can't find your XAML file, and it's clearly right there. So there is a bug file for that. Hopefully they do something about it. But that's totally unrelated to what we're looking at. It's just that when that happens, nothing in the game wants to work. Okay, cool. So we're in the game. It's super pretty. Our player here starts with almost no life, full bar of mana, and we are going to fight some skeletons. So we get into our turn-based combat where right now the player, as a bit of a hack so we can mess around with stuff, is able to freely move around. That's cool. And the one other bug that I'm sure there's more than one, but another bug we're dealing with right now is that vertical targeting to cast spells is backwards. So if I want to cast a fireball at this skeleton, I have to face away from him, which is kind of funny. So that's number one. And then the other thing is that we don't have animations on the actual spells yet. So when I press 2 on the keyboard, it's going to cast a fireball. We're going to see my mana go down. And if we got really lucky, this skeleton that's right here is going to look like he's dying. Okay, let's try it out. I can't believe that. That's super cool. Mostly worked. As I said, nothing ever works the first time. So this is really cool though. So basically, I casted the fireball. The skeleton died really slowly. It didn't loop, which is one of the things I was concerned about, right? Which was, was the animation going to keep restarting? Is it going to basically stutter because it keeps trying to restart itself really fast? Or loop? I don't know. It played through all the way perfectly. That's awesome. But something is clearly broken down here. So I'm not going to debug this on the video, but I'll fix this up. Just want to quickly see what it says. Current frame 6 was out of range. It seems to be that there's something that doesn't handle, I think most of our animations loop. That's probably why. I think all of our animations right now loop, including standing, it loops. So when you reach the end, it doesn't know what to do. And what it should do is just continue the last frame, so I'll probably have to fix that bug. But I am 98% sure that's what it is. Okay, cool. So that's really awesome. We basically faced the wrong way, casted an invisible fireball at a skeleton that was standing above us. It animated its death. We saw the mana go down. And I just got another little bug to fix. But hopefully that kind of helps. Show some of the ways that we add features to the game here. I am going to put a link to the LPC Sprite Sheet generator, and you can check out the GitHub pages and stuff that they have for people that have different resources for that. But I think it's a super helpful tool if you're making games like this and you're not great at art like I am. Not great like art. Like I am also not great at art. There we go. I'm not suggesting I'm good at it. But yeah, I think that's it for today. I'm going to go fix this bug and get both these things pushed up, and that worked better than I thought. Awesome. Thanks, guys.